Welcome back everyone to AP Statistics videos. We are gonna go ahead and get started with lesson 2, which talks about other random sampling methods. Okay, so in our previous video, we talked about a simple random sample. So I want to go ahead and make a note up here. A simple random sample is also abbreviated as SRS. Okay, so that gets used a lot. So let's go ahead and talk about the main idea. When trying to collect a random sample, grouping of the population or the sampling frame can exist naturally or be created. There are 4 main methods. Simple random sample, which we learned from lesson 1, again, is a sample size n in which each set of n elements population has an equal chance of selection. Okay, so the next method is a stratified random sample. Okay, so this is a sampling design in which the population is divided into several subpopulations or strata, and random sample are then drawn for each strata. So if the strata are homogeneous, meaning each of the groups are about the same, but are very different from each other still. A strata sample may yield more consistent results than an SRS. A strata random sampling method will decrease the sampling variability since each member of the sampling frame shares a similar characteristic, such as like your gender, age, or grade level, that may add variation to our sampling data if we perform a SRS. So meaning the chances of someone being picked in each of these groups might be different depending on the size of our sampling frame. So let's say, for example, there's 100 students in the freshman class, and there are only 75 students in the sophomore class, right? A student in the freshman class has a lower chance of being picked than a student in the sophomore class because of the sampling size. Next, we're going to go over cluster random sample. So a cluster random sample is a sampling size in which the entire group or cluster are chosen at random. Cluster sampling is usually selected as a matter of convenience, practicality, or cost. Each cluster should be representative of the population, so all clusters should be heterogeneous and similar to each other. So for example, a cluster would be you are picking you're picking advisories, right? To do a survey. So you pick a freshman advisory, a sophomore advisory, junior and senior, and you would survey every single person in that one advisory. Okay, so here we have and then the last method is that you can also use a systematic random sample if we have a list or roster of all members of the sampling frame. This method works best if your sampling frame consists of people. Okay, of people. So here's an graphic organization and the visual. So a stratified random sample means that we are picking another way to think of it is that we're picking some from all. Okay, so some groups from all, while as a clustered would be like all from some. So it's every single person from some groups, right? And we're going to go over some examples to make this a little bit easier to understand. Okay, so go ahead and go to page 11, and I'm going to show you the steps on how to create to use each of these methods. So let's go ahead and get started with a stratified random sample. Okay, so remember, these are the ones where you put people into groups based on a similar characteristic. So like their age, their grade level, the color of their eyes, it doesn't matter. Okay, so first is you're going to group groups based on similarity. So for example, grade level, okay? Then number each, so number from 1 to n within each group, okay? And then, and then remember that big N equals the number of people or number of elements, okay? So big N is the number of elements, small n is our sample size. So for 2, we use a random number generator to select n in each group. Okay, and then 3 is still the same. It's our response variable. So what we are measuring. Okay. Now we're going to move on to cluster random samples. So cluster random samples means these groups are heterogeneous or representative of the entire population. Okay. So this is like a group that could be very, that is very diverse, very representative of the population, and we pick a few groups and we would measure, or we would survey every single person in that group. So then remember here, groups are heterogeneous. So heterogeneous / they are representative. So representative of the population. Okay. So for example, this would be families or in our case, advisories, that type of thing. So if one is number the cluster 1 through n. 2, use a random number generator to select number clusters for sample. And then for 3, same thing, is our response variable, what we are measuring. Okay. Now we're going to get to systematic sampling. So systematic sampling is basically you're finding a system to pick your sample size. So for example, you're picking every third person in from a list starting at number 5. So then you'd pick 5, 8, 11, 14. Or it could be you pick every third person starting from the number 1. So you pick 1, 4, 7, etc. Okay. So first step is that you get a list. So remember, for a systematic sampling, usually used for list of people. Okay. So we have a list, and you're going to number each person. Okay. Then using a random number generator, you're going to use this to pick our starting value. Okay. And then from there, it's up to you to pick the number to skip, meaning every 10th, every 5th, etc. Okay? And then our last step is still the same thing. It is our response variable, so whatever you are measuring for that problem. So we're going to go ahead and go to the next page and do this model problem. So the model problem is very similar to what we were doing before, just with a little bit more context now. So let's go ahead and read this. The EPA wants to test 20 randomly selected location near a former industrial waste dump and check each for evidence of toxic chemicals. 60 of the locations are located in flat, rich soil area, and 40 of the locations are located on a bed directly next to the flat, rich soil area. The locations in the flat, rich soil areas are set up using a grid pattern of 20 rows and 3 columns, and the location in the riverbed area are set up using a grid pattern of 20 rows and 2 columns. See the diagram below for the visual of the waste dump. So here we have our flat, rich soil area, and this is our riverbed right here. Okay. Part A says, describe how to randomly select a sample using a stratified sampling method. Okay, so a stratified sampling method, as you remember, is that we are picking we are picking some from all. Okay, so in this case, we're gonna be picking some from the flat, rich soil area and some from the riverbed. Okay. So to figure out how to do this in a way that it's equal chances, right? We know that for the flat, rich soil area, we have 60 plots. Okay, so 60 of those squares out of the entire 100 is equal to that. Okay, so there's 60 plots out of the 100. Okay, and we're trying to figure out how many plots out of the 20 would make that proportion the same. Okay, so if we were to cross multiply, we get 100x is equal to 1200. X is equal to 1200 over 100, which is equal to 12. That means that we need to pick 12 soil types from the flat, rich soil. Okay. And then from there, since we're picking 12 from the flat, rich soil area, and we know that we want a total of 20, that means that, so this is from our soil. That means that our sample size, so NS, small n, I'm going to write it over on the left side. Sample size for our flat, rich soil area is going to be 12. Since we want a total of 20, we know that the riverbed has to be 8 to get us that amount. Okay. So now we're doing a stratified sampling method. So remember, this is sum from all, right? So we have our two groups. Our first group is the soil type from A, which would be flat, rich, and the second one would be our river bed. Okay, so starting with our flat, rich soil, first step is number from 1 to 60, because there's a total of 60. Use a random number generator to pick 12 plots. So remember, we're finding 12 of them. And okay. And 3 is we're going to measure the toxic chemicals in each of those plots. Same thing occurs for the riverbed. You're going to number from 1 to 20. Use an RNG to pick 8 plots. And then step 3 is the same thing. You're going to measure the toxic chemicals. Okay? Next, what you're going to do is, so I want to backtrack real quick and talk about what they labeled the rows and columns as. So if we were to turn the page such that the riverbed and flat rich soil was at the top, right? So if you were to turn your paper 90 degrees to the right, this would be our row, and this would be your column. Okay. So this is our columns. Okay. So now part B asks us to describe how to randomly select a sample using a cluster sampling method. So remember, for a cluster, right, we want it to be representative of population. Okay, so what this means is that however you choose your you create your groups, there needs to be both types of soil there. So some from the flat rich soil, some from the riverbed. Okay, so in order for us to do this, in this case, we're going to use the rows because they have both soil type. Okay, so then our first step is to number from 1 to 20 because there are 20 rows, and then use a random so we want it to number from 1 to 20, and then remember that our we want our sampling size to be 20 randomly selected location, right? So each of these rows has 5 columns, so that means that you need to pick 4 rows to get our sample size of 20. So random number generator to pick 4 rows, since 4 rows times 5 columns equals sample size 20. Okay, and then 3 is still the same thing. Measure our chemical measure chemicals in ppm, so toxic chemicals in ppm. Okay, so let's go ahead. I want you to pause this video, go through the check my understanding and the practice problems. Once you have finished that, you may go ahead and unpause this video to check your answers. So now that you've had some time to go over these problems by yourself, I'm going to go over the answers. So under the check my understanding, a survey of public opinion concerning state aid to a particular city, every 40th person registered as a voter was interviewed, beginning with a person selected at random from among the first 40 listed. This is an example of, so our key word here is that it's every 4th person. So go ahead and highlight that. Every 40th person registered as a voter was interviewed, okay? And then it says that it began with a person selected at random. So remember, we have a list of people. It's some number of people that's being surveyed. So that means that our answer is C, a systematic random sampling. Next, 2 says you are going to conduct a survey of your senior class concerning plans for graduation. You ask a senior seminar teacher to randomly select 5 students from each seminar class to take the survey. This is an example of, so here it is some students, so selecting 5 students from each, okay? Selecting 5 from each. So this is saying some from all classes, okay? So since we're doing some from all classes, our answer choice is A, is stratified random sampling. Okay. Okay, let's go ahead and do this next one. Describe how to find the desired sampling using a stratified random sample and a cluster random sample. So, this one is the question about the library hours changing. So, a student organization wants to assess the attitudes of students towards a proposed change in hours the library is open. There are 80 members of the senior class, 100 juniors, 120 in the sophomores, and 135 freshmen. Also, the school has 25 homerooms that students belong to, which all have all high school grades represented within them. So we're going to go ahead and get started with the stratified random sampling. So remember, this is the one where we're choosing some from all, okay? So number 1 is you're going to number each student in each class. So for the freshmen, that would be from 1 to 135. For the sophomores, it's going to be 1 to 120. And then for the juniors, it is 1 to 100. And for your seniors, it's going to be 1 to 80. Then, using a random number generator, you're going to pick, it doesn't say here how many students in total they want, so let's just pick a random number. Let's pick 10 students from each class. Okay, and then for 3, we are going to measure opinions on library hours changed. Okay, so now that's for a stratified random sample. What happens if they're asking us to do a cluster? So for a cluster, this is looking at the homerooms, because the homerooms represent all of the grades, right? There's some freshmen, some sophomores, some juniors, and some seniors. Think of it as like if you had a learning lab that had mixed grades in it. That's basically what's happening here. So for number 1, our first step is that we're going to number the homerooms from 1 to 25, and then using a random number generator. And again, it doesn't tell us how many students or how many homerooms, so we're just going to pick a random number to choose 2 homerooms. Okay, and then number 3 is the exact same thing from before. Okay. The extension question to this problem is that how would you choose the sample using a systematic random sampling? Okay. So remember that a systematic random sampling is you're choosing every whatever, like every every 5th person, every 10th person. So here, the total amount of students, if you add all of these numbers together, the total is 435 students. So you're going to number the school roster from 1 to 435. Then you're going to use a random number generator to choose a starting point and pick every 10th student. Okay. And then number 3 is the exact same from above. So I'm going to go ahead and label this one would be cluster, and this one is a systematic random sample. Okay. Okay, let's go ahead and do this one. There is suspicion that there is a cow contamination in a local city. There are 10 dairy farms in that area. 4 have Holstein cattle and 6 have Ayrshire cattle. Each dairy farm has 15 cattle. For this situation, which method is a better representative sample? So, for this one, the answer is our stratified random sampling. Okay? The reason for this is we get a better representation of both cow types when we choose some from each group. For a cluster, we would sample all from one group, but what happens if the groups we chose was all of the H cattle or all of the A cattle? This becomes non-representative of the population. Okay, so to summarize what I just wrote here, stratified random sampling gives us a better representation, because remember, we group each of these cows based on their cow types, right? So either the Holstein or the Ayrshire cattle. Then from there, if we pick randomly from the first group, randomly from the second group, we get a better representation because we get both of the breeds. While it's with the cluster, if we're grouping them based on their location, you might end up with 2 or 3 groups that is all of just one type of cows. And now, how do you know if you have a contamination based on, the cow types, the location, or, none? While a stratified random sampling, you're in different locations, but you have different cows, so you are getting rid of the some of the variability that could occur. Okay, so that concludes the end of lesson 2. If you have any questions, make sure you put them in the comments or email.